let's also discuss non-polar covalent bonding. Non-polar covalent bonding. So non-polar. So we said with the polar covalent bonding, it involves unequal sharing of electron pair between the two atoms after the donation in a covalent bonding. But for the non-polar covalent bond, it involves equal sharing of electron. So over here we have equal sharing of electron. Equal sharing of electron pair between the two atoms involved in the covalent bonding. Non-polar covalency usually occurs between the homonuclear diatomic molecules because they mostly tend to have the same electronegativities. Is that okay? So examples, we can have H2, we can have O2, we can have N2, F2, Cl2, etc. All these are homonuclear diatomic molecules. Not only these ones exhibit non-polar covalency, we have other examples of non-polar covalency that we are going to use the concept of dipole moment to predict whether a compound is polar or non-polar. But for equal electron sharing pairs, we are going to use the homonuclear diatomic molecules to indicate that as well. Is that okay? Now let's look at some illustrations with these examples. So let's take H2, the first one. So we have H2. H2 means that we have two atoms of hydrogen. So we have one hydrogen atom and another hydrogen atom. Each hydrogen atom, we have one valence electron to indicate its Lewis dot symbol. Is that okay? So there's going to be donation and then electron sharing. So I'm using the dash here to indicate the electron pair shared between these two hydrogen atoms. There is electron sharing, so it means there is what? Covalent bonding. Now, this hydrogen and this hydrogen, they are the same element and they have the same electronegativity. So based on that, there's no upper hand here. No one is stronger than the other. So it means that the electron pair that is being shared between the two atoms becomes equally shared. Is that okay? So this won't give rise to any unequal sharing here. They all have the same electronegativities. Is that okay? They all have the same electronegativities. Now, we can look at another example, N2. In N2, we have two atoms of nitrogen. Nitrogen having 5 valence electrons. So let's indicate that with the dots. So there's going to be donation and then electron sharing to help nitrogen attain stability. So there will be donation, electron sharing, and donation, electron sharing. So that 2, 4, 6, 8. This is stable. 2, 4, 6, 8. This is also stable. Don't forget that we have two nitrogen atoms here and they all have the same electronegativities. So the electron that is being donated and shared is equally shared. There's no atom having a high tendency to pull the electrons more onto itself. No. Because they all have the same electronegativities. This type of covalent bonding is known as the non-polar or the pure covalent bonding. The pure covalent bonding. Because the electron pair that is being donated and it is to be shared between the bonding species is equally shared. Is that okay? It's equally shared, unlike the polar covalency, which involves unequal sharing of electrons due to the electronegativity differences between the two atoms involved in the bond. So that is non-polar covalency. Let me illustrate another example. Let's take F2. So in F2 we have two atoms of fluorine. Don't forget, each fluorine atom has 7 valence electrons. So 2, 4, 6, and then 7. So 2, 4, 6, 7. So for F2 to be formed, there's going to be donation coming from each one here, and then electron sharing. Is that okay? But since they are all of the same species, they have the same electronegativity, so the electron pair will be equally shared. Is that okay? It will be equally shared. So this is non-polar covalency involving equal sharing of electrons as well. There is another type of covalent bond that we need to know, that is the third type, known as the dative or the coordinate covalent bonding. Let's discuss that one as well.